Okay, so now what we're going to do is we are not going to do graphing and solving linear systems of equalities. We're going to graph linear. We're just graphing linear inequalities. So we're not doing systems. We'll talk about that probably the next unit. But we're just going to be doing linear inequalities. Okay. So when we graph a linear inequality, it's pretty neat. You know, we're starting to get more and more into algebra. So you're going to have a boundary. Think of your inequality as basically a slope-intercept form, having an equation in slope-intercept form. That's what we'll want to put it into. The boundary is going to be the line as if it was just y equals mx plus b. And then, depending on our inequality symbol, it'll be a solid line if it has a less than or equal to or greater than or equal to. And then it'll be a dashed line if it has a less than or greater than symbol. So that's one thing that we want to go ahead and consider when we're graphing this. We'll use a test point to determine which side we're going to shade. Yeah, we shade on this. And then we'll shade a half plane that contains the solution. So let's go ahead and get into it here with our first problem here. And we have 3x minus y is less than 2. Well, what we want to do with this is we want to put this into basically slope-intercept form, just like we would do for a regular equation. So I have negative y is less than. The only thing that's different is I'm using a less than symbol. Negative 3x plus 2. So then what I want to do is I can't have a negative y, so I need to multiply it by negative 1. Y, because I had a negative coefficient, I'm going to switch that, is greater than 3x minus 2. So here's where I want to graph it. So I'm going to say 3x minus y. I'm putting the original inequality there, not equation, inequality. And so I graph it. My y-intercept, when I look at it over here, is negative 2. So there's my point. And I have a slope of 3. Up 1, 2, 3 over 1. Up 1, 2, 3 over 1. Because it's a less than symbol, okay, I don't draw a straight line. I'm going to draw a dashed line to connect these points. I know I kind of did dots, but it should be a dashed line to connect these points. Now the question is, what side of this line actually represents the solution to this inequality? In order to find that out, I'm just picking a point from either side. I'm just going to pick the easiest point I know, and that's going to be 0, 0. So I'm going to say x is 0 and y is 0. 3 times 0 is 0. 0 minus 0 is 0. Is 0 less than 2? Hopefully you said yes. And what we want to do is we would shade in, because that's one of the solutions, we're going to shade in this side of the graph. Okay? And that's it. Okay. Put arrows on my line to indicate that it does continue. So now what we want to do is we want to go ahead and move on to 2x minus 1. Let's try another one. Is less than 1. So I have negative, I think I said minus 1. It was 2x minus y is less than 1. Negative y is less than negative 2x plus 1. Okay, again, I can't have that negative y, so I want y, but it's going to be greater than 2x minus 1. So here I write down my original inequality. 2x minus y less than 1. Now I'm going to go ahead and graph it using my slope-intercept form. And so I have a y-intercept of negative 1 and a slope of 2, up 2 over 1, up 2 over 1, up 2 over 1, down 2 over 1. I want to connect that with a dashed line, because of this inequality symbol. Okay, that's why. Now, Here, you might not be able to see it as well, but 0, 0 is a point that we can certainly test it with. So I'm going to put 0 in for x, 0 in for y. 2 times 0 is 0, minus 0 is going to be 0, less than 1. Is that a true statement? Absolutely. So we'll shade in this whole side of the graph. Okay, let's move on. I have 0 plus 6y less than 12. So I have 6y less than negative x plus 12, y less than negative 1/6 plus 2. So I go ahead and I graph that. I got that by 12 divided by 6 is 2. My y-intercept of 2, my slope of negative 1/6. So down 1 over 1, 2, 3, 4, 5, 6. Up 1, back 1, 2, 3, 4, 5, 6. It is not the steepest of slopes because of that less than symbol. I'm going to do that. Okay, here my original inequality, x plus 6y less than 12. Now I'm going to go ahead again and put that 0, 0 in. It's my favorite point tonight. So x is 0 plus 0, 0 less than 12. You bet it is. So we'll shade it in like that. All right, finally, 9x minus 3y greater than or equal to 18. Again, I want to solve for that y, so I have negative 3y is greater than or equal to negative 9x plus 18. Divide by negative 3, so I have y less than or equal to, and it would be 3x plus, 3x, because I'm dividing by negative 3, it would be minus 6. So that's my y-intercept, negative 6, down 1, 2, 3, 4, 5, 6. See how we have to put it into slope-intercept form. So my original equation was 9x, inequality, My original inequality, 9x minus 3y, greater than or equal to 18. So I have a negative slope. No, I don't. I have a positive slope. So up 1, 2, 3 over 1. Up 1, 2, 3 over 1. 1, 2, 3 over 1. And this is a solid line because it says less than or equal to. Now I'm going to use my tried and true, my 0, 0. And that says 0 minus 0, or 0 is greater than or equal to 18. That is so not true. So all we do is we shade in the other side. We'll work more on this in class on Monday, and also we will talk about how we can do this using our graphing calculator. Thank you.